Hey guys, so today we're going to continue with 4.6, chapter 4.6, and talk about the equilateral triangles. So you'll remember yesterday we talked about isosceles triangles. Okay, remember an isosceles triangle is where you have a triangle, right, that has two congruent sides. And since those two sides are congruent, then we know our two angles are congruent, okay? So that was just a quick reminder, isosceles, two congruent sides, and matching two congruent angles. Today we're going to talk about equilateral triangles, okay? So you might remember at the beginning of the unit we talked about equilateral, right? It means equilateral, so equal sides. So according to our equilateral triangle corollaries, a triangle is equilateral, right, if and only if it is equiangular, right? So we want to think about what these words mean. Equilateral, we have equal sides, and then equiangular, equal angles. So if angle A equals angle B and is also congruent to angle C, then all of our sides are going to be congruent as well. Okay, so 3 congruent angles inside means 3 congruent sides of our triangle, right? Additionally, we can say that each angle of an equilateral triangle is going to measure 60 degrees, right? And you think, well, why would it equal 60 degrees? Well, what do we know about triangles? Okay, so a triangle has 180 degrees, okay? And if I know that all 3 of my angles are congruent in an equilateral triangle, then I can say 180 divided by 3, which gives me 60. Okay, so just to make sure we know DE, so if this side is congruent to this side and this side as well, right, then all of our interior angles are going to measure 60 degrees. Okay, so let's work on a few problems to figure out any missing angles or measurements. Okay, so for this example, we're going to be finding the missing measures. Right, so example A, I want to find the measure of y. Okay, I need to find this angle right here. So I'm going to look at my information. Okay, I see that xy right here is 8 inches, and then xz is also 8 inches. Okay, since these sides are congruent, I'm going to mark them as such. All right, what kind of triangle is that? Well, thinking back to yesterday, when we have two congruent sides, we have an isosceles triangle. And remember, whenever we have an isosceles triangle, our angles are congruent as well. Okay, so I'm going to say angle Z is equal to angle Y also. Okay, so let's kind of write down what we did. So I know XY is equal to XZ. That's my sides. I guess I could write my Z a little less like a 2, right? Since these sides are equal, we can say XY is congruent to XZ, okay? Then we address the fact that this is isosceles, and when we have isosceles triangles, our two angles that are opposite the sides are congruent as well. So now I know that the measure of angle Z right here is congruent to the measure of angle Y. And again, that's by our isosceles triangle theorem. Okay, so now I can solve for the measure of angle Y. All right, and how am I going to do that? Well, thinking about triangles again, a whole triangle is 180 degrees. So if I add these two congruent angles plus my known measurement of 60, I should be able to figure out what's missing. So I'm going to write that down as such. So I will say the measure of angle X, right, this one right here, plus the measure of angle Y plus the measure of angle Z has to equal 180 degrees. Okay, all I'm doing is adding my 3 interior angles to the triangle sum of 180. Because remember, triangle sum theorem, 180 degrees. Right now we're just going to substitute in what we know. So I know measure of angle x is 60, okay? And then the measure of angle y and the measure of angle z are the same. Since I know that y and z are congruent angles, I can substitute in y for z as well. So this is what we're doing. So 60 plus the measure of angle y plus the measure of angle y again, because remember, the measure of z is congruent to the measure of y, right? So that's going to give us a sum of 180. Okay, now we just add 60 plus combine like terms. So we have two measures of angle y. Okay. Get this, since we're solving for this, we need to get it by itself. So I'm going to subtract 60 from both sides. So we get two measures of angle y is 120, right? And then dividing by that, the measure of angle y will equal 60, okay? So let's look at that. Y is going to be 60, okay? And what do we know about y and z? These are congruent as well. So we actually have 60, 60, 60, an equilateral triangle. Okay? And then let's see, our last thing we need to solve for is side YZ. Well, YZ is right here. We know that all three angle measurements are 60 degrees, okay? So since all three measurements are 60 degrees, we have an equilateral triangle. And what do we know about equilateral triangles? All sides are congruent, okay? So this last side is going to be congruent to this 8 inches. So it's 8 inches because we have an equilateral triangle. Right? Last example. Okay, so find the value of each variable. All right, so let's look at what we have. We're told that angle A and angle B are both 2x degrees. Okay, we know that by the inverse of the isosceles theorem. Okay, so remember that was the one where we learned yesterday, if we have two congruent angles, then the sides opposite are going to be congruent as well. Okay, so look at what we have here. We have two congruent angles of 2x because angle A is congruent to angle B, right? That's going to make BC here on the right congruent to AC. Okay, that's by our inverse of isosceles. Okay, let's look at what that leaves us with. We have two congruent sides here, but this side was also congruent here. So we have three congruent sides. Okay, so all three sides are going to be congruent. Okay, so three congruent sides. So that means all sides will be 3 inches. Okay? And then last but not least, knowing what we know about equilateral triangles, how many degrees is each angle? Okay? Well, in an equilateral triangle, each angle, so equilateral triangle, each angle again is 60 degrees. Okay, and remember we learned that earlier from our corollaries. Okay, so if each angle is 60 degrees, we can say that 2x equals 60. So So the 2x I pulled from here. 2x equals 60, right? Which means x is going to equal 30. Okay, so again, we just have another equilateral triangle. I know that all three sides are 3 inches because of this, all right? And if we need to find out what y is, remember, 4y minus 5 is equal to 3 inches because these sides are congruent. So we'll just set that equation up. So 4y minus 5 equals 3. It's going to give us 8. And then divide by 4. So y equals 2. Okay? Great job today, you guys.